So in today's lesson, what we're going to do is we're going to be talking about solving and graphing inequalities. So we're still working with linear equalities. We're going to start in one dimension on the number line and then generalize it to 2 dimensions. We will eventually be working with 3 dimensions, just not yet. So let's go back to an inequality. Here you have -2 is greater than or equal to x. I personally always like to have the variable on the left-hand side. So I would rewrite this as x is less than or equal to -2. That helps me graph things. You don't have to. I like to do it. So if I were to graph this on the number line, x can be any number that is less than or equal to -2. So at -2, do I have an open or a closed circle? Closed, because of the or equal to. And again, if you isolate the variable on the left, you're going to shade the direction of the inequality. So that's what our solution set would look like. Now, given a value, you should be able to determine if it is a solution. To determine if something is a solution, you just take the value of the variable, substitute it into the original, in this case, inequality. If I get a true statement, it's a solution. The hints for the PSAT: substitute, right? Reverse engineer, get your answers and substitute when you can. So if I were to ask you, is -2 a solution to this inequality? Does it belong in the solution set? Is it a valid value for x? You could easily substitute it into the inequality. And so if I substituted it into the inequality, is this a true statement? Yes, it is. It is equal. So it is a solution. What else could you have done graphically? You could have just looked at the graph and said, oh, -2. Is it shaded? Yes, it is. What about -10.5? Is it a solution?
Yes.
Yes, of course. It is shaded, and if I were to substitute it into the inequality, it would be true. Is 0 a solution? No. Look where it is on the number line. It's not part of the shaded region. So if I were to say, okay, well, what if I wanted to represent the solution set, the graph, this inequality, using interval notation? Because you know I often ask for things to be represented in interval notation. What would the interval be? Bracket.
Parentheses.
Open parentheses.
-2 bracket.
And close. Very good. Excellent, excellent, excellent. So if I were to be given words, or if I were to be given, like for an example in a word problem, if I was given an inequality, you should be able to translate that in terms of the words that can be used to describe it. So for example, if I'm writing inequalities from words, if I see the word less than or fewer than, you should think of the less than symbol. If I see greater than, or it must be a more than something, we should see the greater than symbol. If it's less than or equal to, or at most, or no more than, then it would be less than or equal to. And similarly, greater than or equal to, or at least, or no less than, you should think of this inequality symbol. So let's say you've been given the following words and you're asked to represent each scenario using an inequality and then graph the solution set in the numbers represented on the number line. So yesterday you went and exercised. You ran for 20 minutes. So you ran for 20 minutes and biked for more time than you ran. More time than you ran. Write an inequality that represents the amount of time you could have biked for. So you're going to have to introduce variables. If I don't define the variables for you, you're going to have to define them yourself. So I need to represent B as the time I biked for. So I need to have an inequality that represents that. So if I ran for 20 minutes and I biked for more time than I ran, then how could I represent the inequality? B would be what? Greater than 20. So if you're graphing the solution set on the number line, I would find 20. And again, it doesn't matter how you represent this. I like to always see 0 and then maybe, let's count by 4. No, let's not count by 4. Let's count by 5. 5, 10, 15, 20. So is it open or closed circle? Open and shading to the right. And again, if I wanted to represent that just for kicks as an inequality, the inequality would be open at 20 to positive infinity. Always open with infinity. A few things I noticed is that some people, when they're writing intervals, don't always put the smallest value first. In an interval, the smallest value always goes first. Okay, let's look at the next one. To order from the child's menu, you must be at most 12 years old. At most 12 years old. Write and graph an inequality that represents the ages you can be to order from the kids menu. So I have to define a variable. I'm going to go ahead and set let A equal the age to order from kids menu. Get in the habit of defining variables so that we can get ready for more interesting problems. And now I want to represent that as an inequality. So A would be what? Okay, and what would that be? You have to be at most 12 years old. Less than or equal to 12. So I'm coming to the number line. Again, I like to see 0. Maybe 2, 4, 6. Oops, I say 6, I write 8. 6, 8, 10, and 12. What's happening at 12? Okay, and on the graph, what does that look like? Closed circle and shading. No, to the left. Now, technically, we're saying less than 12, right? But we know in terms of this word problem, you can't be less than 0, right? So, I mean, technically, you should go from, well, if you're 0, you're not really ordering anything. But technically, in terms of the word problem, it would just be this line segment, right? Technically, in terms of this. But this is what we're discussing right now, just understanding the difference between the 4 inequalities. Any questions? Okay. Now, what if I were solving these inequalities, graphing the solution sets on the number line, and then, of course, making sure we can write intervals that represent each of these. So if I'm solving for x in this example, what might I do first? Divide by a -5. Now, knowing our rules for solving inequalities, I'm dividing by a negative, so what do I have to do? Change the direction of the inequality so it becomes a less than. Then I actually perform the division. So I'm going to get x is less than -9. I'm going to graph that on the number line. I like to see 0 and then, -3, -6. I mean, I don't care what your scale is. Open circle at -9, shading to the left. Corresponding inequality would be what? Interval.
Negative infinity to negative difference.
And open. Yeah, very good. Okay, looking at the next one, I want to solve for x. So I have to isolate the x on one side of the inequality. What is the first step? Subtract 7. Okay, do I have to change the direction of the inequality for this one? No, because I'm just subtracting 7. So I'm going to get 2 is less than or equal to x. Again, I like to see it with my variable on the left-hand side. It's not necessary. I'm just showing you that this is equivalent. And then I like to see 0, and then open or closed at 2. Closed, shading to the right. And that interval would be what? Close bracket 2 to infinity, right? Because it's or equal to. Okay, look at the next one. How am I going to solve for x? Multiply both sides by 4. That's going to give me x is less than 20. Again, show me 0. I just like to see it. And then maybe 2, 4, 6, 8, 10. Oh, no, that's bad scale. Let's count by 5, 10, 15, 20. Open or closed at 20? Open and shading which direction? Which direction? To the left. And the interval that corresponds to this would be what? Beautiful. Open parentheses, but close parentheses. Yes, yeah, but open interval. Okay. Ooh, look at the next one. The next one, I have a negative 3/4. How am I going to address that and isolate the x on the left? Not divide by negative 3/4. Yes, multiply by the reciprocal. So for the reciprocal is negative 4/3. Remember, because I want to get just x on the left. So I'm multiplying by the reciprocal on both sides. So it's gone here. So that's going to leave me just x. And then what? Anything I have to pay attention to? I have to first change the direction of the inequality. And yes, pay attention, because I divided or multiplied by a negative across the inequality. So change the direction of the inequality. And then yes, you are correct. Both are negative. So that gives me, I don't care if you want to multiply first and then reduce the fraction, or if you want to simplify first and then perform multiplication. Do you have a preference? Multiply first. Okay, so then I get 36 over 3, and then I would have to reduce that and get x is less than what? 12. 12. Okay, show me 0. And then what are we counting by? 2, 4, 6, 8, 10, 12. Open or closed at 12? Open, shading, left. Interval? Yes. Excellent. Excellent, excellent. Word problems. You need to make at least 150 sandwiches for a charity event. So at least 100. So more than that is okay. 150 is fine. More is good. But you can't make anything less than that. You've already made 20 sandwiches. We have to write an inequality to solve for the possible remaining number of sandwiches you have left to make. Solve and graph the inequality. Solution set on the number line. So let's first define the variable that we're solving for. So we are trying to figure out how many sandwiches to make. So maybe, should we let S equal the number of sandwiches to make? And how am I going to represent this information as an inequality?
X is greater than or equal to 150.
Why would you subtract the 25 I've already? Plus 25. That's right. So I have sandwiches to make. That number of sandwiches plus the 25 I already have has to be greater than or equal to 150, right? Yes, and that would be the next step in solving this. But if I wanted to represent exactly the information that I have been given, it would be I have to make some number of sandwiches S. And if I add the 25 I already have to that number, that total number has to be greater than or equal to 150. Now, you are absolutely correct in saying that, oh, well, technically I'm just subtracting that from the 150, and I have S is greater than or equal to 125. So then I find that on the number line. I'm just going to say 0. Oh, heavens, what are we counting by? 50? 25? 25, 50, 75, 100, 125, 125. So here we go. Open or closed at 125? Closed. And shading to the right. Of course, we should be able to represent this as an as an interval. So what would the corresponding interval be?
Closed 125, open infinity.
Okay. I'm hearing it come through my speaker here. Closed 125 to open infinity. You are absolutely correct. Absolutely correct. Okay, let's look at the next example. You go to the grocery store to buy some bananas. You have $18. You only have $18. Okay? You can't spend more than that, right? A banana costs $1.50. The expensive bananas. Write an inequality to solve the number of bananas you can buy with that $18. So let's define the variable. What do we want it to be? X. You like X? Come on, it's not fun to choose a variable that you can choose X. I'm choosing B. I want my bananas to be B. B equals the number of bananas to buy. It doesn't matter what variable, what letter you choose. That's why we're defining it. Now, I have $18. I can't spend more than that. A banana costs $1.50. Can anybody tell me the inequality I would use to solve for B? Yes, and I'm going to write it in the other order, an equivalent way of writing that. $1.50 for every banana I buy, and I can spend no more, so less than or equal to $18. If I'm solving this, I'm dividing each side by 1.5. And what do I get B to be? B is less than or equal to 12. So I can only buy 12 bananas at most if I want to spend my $18. So again, I like 0, 2, 4, 6, 8, 10, and 12. Open or closed at 12? Closed. Shading? Which direction? Left. If I wanted to represent this as an interval, what would it be? What would the interval be? Correct. Excellent. Now, that's all in one dimension. That's just on the number line. What if I now step it up and go to 2 dimensions? So now I'm looking at linear inequalities in 2 variables. So a linear inequality in 2 variables is just like an equality, like an equation, like the graph would be a line. The only difference is we are replacing this little equal sign with one of these inequalities. So when we're graphing the solution set to the linear inequality with these less than, greater than, less than or equal to, greater than or equal to, I'm shading a half plane. Okay? I have a boundary line, and the way I'm going to identify the boundary line is by looking at whether I have open circles on the real number line on the boundary line, which would imply a dotted or dashed boundary line. And then if I have or equal to, that boundary line is going to be solid. So let's talk about how to graph them. Now, we know when we graph lines, we like to see them in slope-intercept form. So if we rewrite the equation in slope-intercept form, we can easily identify the y-intercept, plot that point, rise and run the slope. And then once we have those 2 points, we look at the little inequality and we say, hey, is it a dotted or a dashed boundary line? And then I have to determine what side, which half plane I am shading. Easiest way to do that is find a test point, substitute back into the original inequality, and see if you get a true statement. If you get a true statement, you shade the side that has that point. If you get a contradiction, if you get a false statement, don't even think about shading that half plane. Shade the other half plane. Now, I personally like to always choose 0, 0 unless I'm passing through 0, 0. So let's go ahead and do that. Let's first rewrite this inequality, this linear inequality in 2 variables in slope-intercept form. What is the first step to do that? Subtract x. Okay, so I have it in slope-intercept form. From there, I can identify the y-intercept, which is what? The point. We always write intercepts as points. 0, 2. So I'm going to plot that. There's my y-intercept, 0, 2. And tell me, what is my slope?
1.
Slope. What is your m? Y equals mx plus b. Negative 1. So from this point, I'm going to go down 1 and to the right 1. I have 2 points. So now I have to look at my inequality to understand, what does my boundary line look like? Now, it is a less than symbol. So is it dotted or dashed? I mean, dotted or solid? It's dotted, dashed, whatever you want to call it. Now, let's try to make these look good. Okay. Now, what else do I always have to do when I'm graphing? So you don't lose points on a quiz or a test. Label your X and your Y axes. Okay, you don't do that in the future, you get points off. 2 points every graph. Those add up fast when every single problem you have to graph on a test or a quiz. Okay, so I have my y-intercept, I have my slope. I know it's a dotted dashed line because of the inequality. So now I have to determine which side I'm going to shade, which half plane. You know, planes go on forever, but we're kind of cutting it, right? So it's called a half plane. So I'm going to choose a test point. So the test point I like to choose is the origin, unless I pass through the origin, but I don't. So I'm going to test 0, 0. So I'm going to come back into my original problem, or an equivalent version. I'm going to go ahead and put it in this one. Either one will do. You can go back to the original, or you can go back to any version of it. And I'm going to substitute in 0 for x and 0 for y. So 0 is less than 2. Is that a true statement? Yeah, 0 is less than 2. So I'm going to shade the region that has 0, 0, because I just tested it and it's true. So there's my graph. Okay, let's do another one. I want to graph this linear inequality on the Cartesian plane. What do I do first? Okay, so how am I going to do that to get it in slope-intercept form? Okay. That's going to give me negative 3y is greater than or equal to negative 2x plus 6. Then what? Oh, divide by negative 3. What do I have to be careful of? Change the direction of the inequality because I am dividing by a negative across the inequality. I don't like to hear that. We're changing the direction of the inequality. I mean, flipping it, that could mean so many different things. That's not a math term. Do we get this in slope-intercept form? Do we get this inequality? Okay, now that I have it in slope-intercept form, tell me, what is my y-intercept? Thank you. It's the 0.0, -2. Plotting it. I'm rising and running the slope. So what is the slope? 2/3. So I'm going up 2 and to the right 3. Now, is it a solid or a dotted boundary line? It is solid. I have that or equal to, so it is solid. Well, I can't use my ruler. That's pitiful. It's supposed to go through that point. Solid. Then what else? Okay, we want to do the test point now. Okay. So test point, I'm going to test 0, 0 because it doesn't pass through it. So I get 0 is greater than or equal to 6. Is that true or false? That is false. Well, I was substituted it into here. I mean, if I substitute it into here, I'm going to get 0 is less than or equal to -2. That's still false, right? It will always satisfy. Okay, so which half plane am I shading? The one without 0, 0. So down here. Is my graph finished? You label those X and Y axes. Okay, let's do a little bit more. We want to be able to graph inequalities without a test point. Well, if you solve for the inequality to be in slope-intercept form, so we have y is greater than or equal to mx plus b, or y is less than or equal to mx plus b. If you isolate the y on the left-hand side, there's a trick, okay? If you have greater than, you are going to shade above the boundary line. If you have less than, you are going to shade below the boundary line. Now that's great if I have a line that's not vertical, but if I have a vertical line, or if I have a horizontal line, So let's look at that. So if I'm looking at x is equal to a, which is the standard form for a vertical line, if I take that inequality and I replace it with a greater than symbol, which direction am I shading? Bless you. I have a vertical line. Right? So I'm at A. If I'm greater than, I am shading to the right of my boundary line. If I am less than, which direction am I shading? To the left. And that should make sense. You could still test a point. Now, what if I'm dealing with a horizontal line? So let's say I have B here. If I'm shading greater than B, which direction am I shading? I'm shading which direction? Above it. There's B. And if I have less than, I'm shading below. So let's just look at 2 examples. I have y is less than or equal to -3. Tell me, what type of line is the boundary line? It is a horizontal boundary line, and is it solid or dotted? It is solid. So a horizontal solid boundary line. And it is at y equals -3. So there's my boundary line. Now, am I shading above or below? I'm shading below. Is my graph done? Label your axes. Okay, next example. X is greater than 2. Tell me about that boundary line. It is vertical and a dotted. Okay, and it is at X equal 2. Which direction am I shading? You are correct. Am I done? Label your axes. Now let's look at a word problem, because you know that's where it's going, right? We're putting all this together. So we have Walter. He went to a bookstore that sells pre-owned videos and CDs. I know videos cost $9. CDs cost $3. Walter can spend no more than $36. He's walking in there and he wants to know what he can buy. We have to define two variables, write an inequality that represents the situation, solve it, graph the solution set, and then answer some questions. So let's define our variables. I'm going to say let V equal number of videos to buy. And I'm going to let C equal the number of CDs to buy. Now let's write an inequality. Anybody? Excellent. And remember, the commutative property of addition says it doesn't matter on that left-hand side if I write 9V plus 3C or 3C plus 9V. Now, at this point, you have two variables. I didn't call them X or Y. So I have to solve for one variable. So if you prefer to write them in terms of X and Y to help you at this point, instead of saying, oops, if this is going to confuse you, you can just change it to 3x plus 9y is less than 36, or vice versa. It doesn't matter. All I'm saying is at the end of the problem, you need to label your axes according to the variables, knowing which is your independent and which is your dependent variable, which is your kind of X and Y, which is your input and which is your output. So I don't care. We're solving for Y? Is that the way we want to do it? Okay. So then I'm going to subtract 3x. And that's going to give me 9y is less than or equal to negative 3x plus 36. Next. And so I'm going to get y is less than or equal to negative 1/3 x plus 4. Now, for kicks, we're going to do it the other way as well. Just as an aside, because I want to show you what happens when you change that. So let's say I had done 3y plus 9x is less than 36. Do you see the difference? Two totally different equations. Gives us two totally different solutions. I mean, it's going to give us different things. It's going to give us the same answer in terms of the number of CDs and such we can buy, but it makes a difference what you're solving for, right? Now, that was an aside of a point. Let's go back to what we were doing here. Yes. It doesn't matter as long as you define what you're doing. And how you're defining it is how you're labeling your axes. In our case, what was our input? Our input was the videos. I mean, our input was the CDs, right? According to this, if we use X and Y, what was our X? Our X was CDs. So that means I'm labeling my axis where my independent variable X is really C. And this is Y, my videos. So that's why it's important to label your axes. Otherwise, I have no idea what you saw for your input. And if you get a different graph, you're going to get a different graph depending on how you labeled your variables and your axes. So in this case, I have my y-intercept as 0, 4. And I'm going to go down 1 and to the right 3. Is it solid or dotted? It is solid. Now, is there another point on the graph, on maybe the boundary line, that we would be very interested in knowing so we have an accurate graph? I have my y-intercept. I have another point, but what would be another interesting point to have? Yeah, I think I want to see that. So what would the x-intercept be? How would I find the x-intercept? Remember, the x-intercept, I'm looking for an x value, but my y value is 0. Right? So can't I come up here and set my y value to equal 0 and solve for x? Okay, and if I did that, what is 12, right? And I recommend doing that, because otherwise, you know, you're not get a very good graph. Now, am I shading above and to the right or down and to the left? Am I shading down and to the left or up and to the right? Yes, I mean, he only has so much money. And remember, I would be confined to the first quadrant because I can't have negative CDs or negative videos. So really, oops, and I say that and I do something hideous. It's just this little section here that is our solution set. Okay, so what do the intercepts represent? What do the intercepts represent? Well, the C-intercept represents what?
How many CDs you can buy?
Yes. Number of CDs to buy if no videos bought, right? And what does the V-intercept represent? Number of videos to buy if no CDs bought. Remember, that's kind of like that height and arm span problem. I mean, not arm span, and shoe size, right? If you had a 0 shoe size, remember that? And then if it made sense. Now, my question is, does Walter have enough money to buy 2 videos and 3 CDs? How can I determine if I have enough money, if that $36 is going to cover it? What can I do? I can. Now, you can go back to the original or any equivalent version. It doesn't matter. I was going to substitute in 3 for CDs and 2 for videos. Is that less than 36? Yes. Yes, he does. And these are word problems, so we're writing out our sentences, our answers and sentences. Does Walter have enough money to buy 4 videos and 5 CDs? No. Now, I could do that algebraically, but I could also come where on the graph and see if it's true. I could come to 5 CDs, 1, 2, 3, for 5 CDs and 4 videos. 1, 2, oh no, he's out of that solution set region. So no, he doesn't have enough money, and I'm abbreviating, to buy 4 videos and 5 CDs. He's not in the solution set region. And I could prove that algebraically by substituting into the inequality. So how can I state combinations of other numbers of videos and CDs Walter can buy? How can you tell by looking at the graph? Anywhere in this shaded region, you pick whatever you want. He could buy nothing, right? And just keep $36. Or he could buy, 2 CDs and 2 videos and have money left over. So look to the shaded region. Does everybody understand how it makes a difference how you labeled your axes, what you're calling your independent and your dependent variable? If I had graphed this other line here, I'm going to get a totally different graph. I mean, for kicks, if I want to see it, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Down 3, across 1. That's a totally different graph, right? So it makes a difference whether you're saying C is your independent or V is your independent. Any questions on this? Okay, so you have a corresponding My Math Lab that goes with this. So make sure that you do the corresponding My Math Lab. Remember, there's that extra credit. The SAT extra credit, so we can be working on that as well. Upload it. Okay, are there any questions online? And I have to turn this sound on. Any questions? No heaven.
What's the extra credit?
The extra credit is the PSAT practice, reading the definitions. It's an assignment in Canvas, so make sure you look at that.